Wake Pahukwai Tip, it's Jasmine here. Hi everyone, I wanted to present today on my science experiment that I chose to do with my roommates. So we did Oobleck, the non-Newtonian fluid. So I wanted to show you a little preview of our experiment and how it went. We had a lot of fun doing this one.
Okay. Now wiggle it around so it makes waves. Okay.
So this is my slide for the instructions for the Oobleck experiment. All you need is cornstarch and water and a bowl or dish to mix everything in, and then the food coloring and the hammer are actually optional. We chose to just do it with our fists, and that seemed to work out really well. The procedure is that you mix the cornstarch and the water into a bowl, slowly adding the water, trying to get about 2 parts of cornstarch to 1 part of water. And then you make your observations, test theories, and have fun along the way. Clean up by putting the Oobleck in the garbage and never in the sink because it does stay the same kind of consistency. So first thing to do when conducting this experiment is to activate schema and introduce the KWL chart. So this portion of the activity is designed to activate schema or prior knowledge to elicit scientific thinking for observing and questioning. So students will be introduced to the activity's KWL chart, which will assess their learning before, during, and after the experiment in class. At this point, the teacher will activate schema by introducing the experiment and asking students to recall their previous observations with cornstarch. They will also review questions such as, what is a solid? What is a liquid? How do they act? What is the difference? Students will then be given the chance to fill out the no column of their KWL chart. So here's my example of my KWL chart that I chose to create for this experiment with some instructions on the top. So the no portion of the column, which I like to call the pre-experiment assessment. So at this stage, students are being assessed on their schema and were encouraged to demonstrate their prior knowledge of cornstarch and non-Newtonian fluids. So you can see here that he knew about a liquid and a solid and what shapes they had. He also knew a little bit about cooking with cornstarch, so he was able to relate that it was a thickener used in cooking. So next, students were asked to hypothesize and predict. So during this stage of the experiment, students will be exploring their hypothesizing and predicting skills. They will explore thoughts about how this experiment might react, and they will be introduced to the vocabulary of non-Newtonian fluids, or NNF, as I chose to abbreviate. Students at this time will be making a hypothesis and prediction. The teacher will elicit thinking by asking questions like, what do you think a non-Newtonian fluid is? How do you think the Oobleck will act, like a solid or a liquid? What might that look like? What do you think will happen if we hit it with a hammer, or in our case, a fist? Students will then be given this chance to add to their KWL chart in the wonder portion. So wonder, the pre-experiment reflection. At this stage, students were encouraged to reflect on a hypothesis and prediction for this experiment. So my volunteer chose to wonder about what Oobleck was going to be and what a non-Newtonian fluid was. He also said, I wonder if this is the stuff from the video, when I punch it will get hard. So it gets hard under pressure. He had a pretty good prediction. So Oobleck, investigate and interpret. This is the stage where the experiment takes place. Direct students through the intended Oobleck activity. Have them explore their questions, hypotheses, and predictions while investigating the properties of their non-Newtonian fluid. Get students to start interpreting their data as they conduct the experiment. Remind them to reflect on their purpose and collect the data needed to report on the experiment and experience. So now, communicating the Oobleck effect. So what the heck is Oobleck? Simply put, Oobleck is a suspension that acts as both a solid and a liquid. It has properties that allow it to change from a liquid to a solid depending on the amount of force put upon it. It is what is known as a non-Newtonian fluid. So I have a little example video here to show you how it reacts. So this was a video I got off of YouTube, not a video I took myself. So now you might be asking, what is a non-Newtonian fluid? So a non-Newtonian fluid is a fluid that does not follow the law of viscosity discovered by Sir Isaac Newton. Scientifically stated, a non-Newtonian fluid, such as Oobleck, will change its viscosity, its flow behavior, when under stress, a force, becoming more solid or more liquid before eventually returning to its original state. So now I asked my volunteer, can you think of anything else that might be considered an NNF? Write it in the no or wonder portion of your KWL chart. So then we explored some examples. So some examples for your reference of non-Newtonian fluids are honey, ketchup, and cream, known like whipping cream. So now, what learning took place? Reflecting on the purpose of this experiment, it was intended that students become introduced to properties of solids and liquids. They were to explore and reflect on their prior knowledge of these states while also making hypotheses and predictions on the outcome of this experiment. Students also explored learning surrounding non-Newtonian fluids, viscosity, force, and matter. Students utilized the KWL chart writing strategy to demonstrate their thought process and progression throughout the experiment, allowing for easy formative assessment for and as learning. Summative assessment of learning can also be gathered when looking strictly at the L or learn portion of the KWL chart. So learn, the post-experiment assessment and reflection. At this stage, students were directed to reflect on their learning and demonstrate it in the learn portion of their charts. They were also encouraged to review the know and wonder portions to update as they saw fit. So my volunteer had learned that under force, the Oobleck started to change its consistency from a liquid to a solid and back again. So we were able to explore what a non-Newtonian fluid was, and he was able to explain it to me after the experiment. He was also able to recall all of the examples that I had told him during the experiment, although I let him get off the hook a bit for writing this all in his KWL chart, because he was able to gather all the rest of my roommates together and demonstrate to him what he had learned and his observations through the experiment. So along with my volunteer, I also made some observations of our experiment, and I kept them in another copy of the KWL chart. Mostly we observed the same thing, although I tried to give a little bit more detail and write down his thoughts. So if you'd like to explore more, I did make some connections to the BC curriculum, mostly focused around grade 3, but I did explore grades 2 to grade 4 throughout the curriculum. And again, I did try to make some connections to the FPPLs and Indigenous connections. If you'd like to pause and have a read here, you can see that I did try to root it in the First Peoples Principles of Learning. And to further your own thinking, you can pause it again here and see some examples of other experiments or furthering this experiment or connections in other curricular areas. Finally, these are some resources that I used to research my science experiment and for some of the videos and information that I had in this presentation. So, thank you all so much for coming and listening to my experiment today. I hope that you enjoyed this. Thank you.